Okay, I'm just going to sit here and write on this paper, and hopefully y'all can see it on the screen and stuff like that. We're going to talk about it kind of as we go through it like I would any other time. Okay, so big part of your test, or not a big part, a part of your test is going to be knowing these different types of forces. Okay, so this isn't the vocabulary that we've been writing down. This is just types of forces. Okay, this was like the very first note section that we did. All right, so what I recommend is once we match these today, make sure you're studying this. All right, and then obviously you do get to use a test review on the test. So just make sure you're with me, writing down the correct thing, things like that. Okay, so types of forces. Being able to identify which type of forces are working on an object. All right, let's just go through and see what we got. So number one, force due to a rope, pulley, cable, or wire. Does anybody remember what that one is? Tension force. That's going to be H right there. One is H. Tension force. Force of a fluid pushing back on an object. What is fluid?
Buoyant.
Buoyant force, yes. J. Force that typically opposes motion. Does anybody remember that one? Like if I'm sliding my hand across this? Friction, yes. Friction is the answer there. That is letter F. Force a massive object like Earth has for an object. Gravitational force, yes. Forces that directly touch the object. Contact forces, which would be A. Force done by a person or a machine. Applied force. Special type of friction that is due to air. Air resistance. Force of a spring, either stretched or compressed. Spring force, that one's pretty self-explanatory there. Force that is pushing back on an object. E? Did you say E?
Yeah.
Yep, normal force. And then forces that act at a distance would be non-contact forces. Okay, so that's our types of forces. Y'all did pretty well on that before even talking about it, so hopefully you nail that on the test tomorrow. All right, free body diagrams is this next section, and I'm also tying it to net force, where you calculate the net force of a situation. So let me make sure it's all up on my screen here. Be able to draw a free body diagram, be able to calculate net force, and be able to determine which direction the system is moving based on a free body diagram. Okay? So when you draw these on the test tomorrow, I'm not necessarily going to look for is the right arrow the longest arrow that you drew? Are your up and down arrows exactly the same length? I'm not going to be picky on that. Okay? The answer that you get from it and where you put your numbers on your free body diagram will tell me if you understand or not. Okay? So, let's go ahead and draw these free body diagrams, and we're going to calculate net force. Okay? This little symbol right here is the same as net force. Okay? That's a Greek symbol, and it's the sum of is what it stands for. So the sum of all the forces, that would be net force. Okay? So, gravitational force is 98 newtons. Which way does gravitational force go? Down. So I'm going to draw my down arrow, and I'm going to label it with 98 newtons. Okay, so that's my gravitational force. Applied force is 100 newtons to the right. So that one tells me to go to the right. So to the right, and that one was 100 newtons. And then I have 10 newtons of kinetic friction. Which way is that going to go? Left. Okay, friction is going to go the opposite of the applied force or anything like that. Okay? So, I drew my free body diagram. Let's look at net force. Okay, and I probably have a typo on this. I want to add a normal force. Okay, I'm going to write that right here. I I forgot to put that on this question. Normal force of 98 newtons. Go ahead and add that to your question. Tomorrow on the test it'll have that. Which direction is normal force going to go? Up. Okay, that's my fault on that. Alright, so there's my free body diagram. Let's make a note on how to calculate net force. Okay, I'm going to put a star right here as a note. You're going to subtract opposite arrows. Subtract opposite arrows. And then we're going to add arrows pointing the same direction. Okay, that's our two notes for net force. Alright, I'm going to go in with a different color whenever we start adding and subtracting and all of that stuff. Okay? So, let's look at my up and down arrow first. Alright, I have 98 newtons going up, 98 newtons going down. What are those going to do?
Cancel.
They're going to cancel out. So I can just mark those out. Okay? They cancel. What am I going to do with 100 newtons to the right and 10 newtons to the left?
Subtract it.
Those are going to get subtracted. Whenever I subtract those, is this pen working? Let me use this. Okay, I'm going to end up subtracting these guys because they're going opposite directions. So my net force is going to be 100 minus 10, which is 90 newtons. Which direction would this free body diagram be going?
To the right.
To the right. Newtons to the right. Okay, do we understand why it's going to the right?
Yes.
Because that 100 newtons is going to far outweigh the 10 newtons going to the left. Okay, so my final answer would be 100 minus 10 gives you 90 newtons to the right is my final answer on that first one. Alright, let's look at number 2. Gravitational force is 98 newtons. Which way is that going?
Down.
Down. Gravity always goes down. Air resistance is 10 newtons. Which way is that going to go? Up. Air resistance is going to go up. Alright, do I have anything that's going to cancel out? Nope, because 98 and 10 are not the same number. So I'm going to add these or subtract these? Subtract because they're going opposite directions. Okay? So in this one, my net force is going to be 98 minus 10. Oh, minus 10 gives me what? 88 newtons. Which direction? Down. Okay, are we okay on these? We have a third one, but are we getting the hang of it? Okay, y'all stop me if you have any questions. The main thing on these is going to be drawing your free body diagram, knowing which way your arrows go. Okay? Number 3, tension is 100 newtons and gravitational force is 100 newtons. So, I know gravitational force goes down. Which way is tension going to go? If you think about tension, it's like a rope or something. So that means something is hanging from a rope. Tension force is going to go up. Okay? Tension force goes up. What do these two do?
Cancel.
They cancel out. 100 minus 100. So what would our net force be?
0.
0. And with 0 net force, there's no movement or anything like that. There's not going to be a direction. Okay, 100 minus 100 cancels. So my net force is going to be 0 newtons. Okay, are we good on free body diagrams? Alright. Let's talk about Newton's first law of motion. An object in motion tends to stay in motion. And an object at rest tends to stay at rest. Unless acted upon by an unbalanced force, yes. Be able to understand how inertia affects different situations. Know that everything wants to maintain a straight path. Okay? So let's make a note on that second bullet where it says understand how inertia affects different situations. What's the main thing that contributes to like how much inertia something has?
The mass.
The mass. So we're going to write more mass equals more inertia. More mass equals more inertia. Okay, that goes back to the Hulk having more inertia than me because the Hulk has more mass. Alright, what has more inertia? We're going to circle one of each of these situations. Okay, so what has more inertia? A 10 kilogram bowling ball or a 4 kilogram bowling ball? 10 kilogram because it has more mass. Okay? What about a car or a bicycle? A car, because it has more mass. A feather or an apple? An apple. Okay, this one is going to talk about velocities a little bit. Does a tennis ball at 4 meters per second or a tennis ball at 12 meters per second have more inertia? 12. Okay, the one that's going the fastest will have more inertia. Something traveling at 20 meters per second or 19 meters per second? 20. Okay, we have like a concept question here on number 2 and number 3. Why does a zombie fly off the top of your car when you slam on the brakes?
Because your body wants to keep moving forward with it.
Yes. We're going to say the zombie's body wants to continue going at the speed the car was going. Due to inertia. The zombie's body wants to continue going at the speed the car was going due to inertia. Okay, it wants to continue the path that it's on. Okay, number 3 is a very similar question. Why does it feel like your body slams into the side of a roller coaster when it makes a sharp turn? Yes. Okay, so let's draw like a picture on this one. So I talked about this yesterday. So you're going on, the roller coaster takes this path. Okay, that's the roller coaster. So when it takes that turn, your body wants to continue going that way. Okay, so this is the roller coaster. That is your body.
That's not my body.
that's just because of inertia. Your body wants to continue that straight path. Alright, so that is Newton's first law of motion. Let's talk about his second law of motion, where we use our F equals ma equation and that handy-dandy triangle. Okay? Newton's second law says that the unbalanced net force on an object will cause acceleration. Be able to solve problems using the force formula. Be able to distinguish between different variables based on their units. Okay? So let's do this matching part here. What is the unit for force?
Newton.
Newton, so that's letter B. What about mass?
Kilogram.
Kilograms. And then acceleration is meters per second squared. Alright, now let's get to work on the F equals ma equation. This is exactly the layout that the test is going to have. It's going to have this table here. It's where you fill in your information and everything. It's going to look identical, just different numbers. What is the acceleration of a 225 kilogram object that has 225 newtons of force? Alright, where does 225 kilograms go? M. Okay, that's going to be my mass. So 225 is going to go here. Where is 225 newtons going to go?
One.
Force, right. Okay, newtons always goes with force. So that means I'm looking for A. Does anybody know how I'm going to solve for A? Right? So if I look at my triangle here, I cover it up because that's what I'm missing. So I'm going to do F divided by M in my calculations down here. So A is going to equal 225 newtons divided by 225 kilograms. Okay, F divided by M. And what's your answer? 1. And our unit for acceleration is meters per second squared. Okay, make sure on your test tomorrow you don't forget a unit. Okay, know that acceleration's unit is meters per second squared. Okay. Number 2, an object experiences 10.2 meters per second squared acceleration when pushed with 114 newtons of force. Find the object's mass. This meters per second is what type of unit? F, M, or A? Acceleration, yes. Okay, so A equals 10.2. Where do newtons go? For force, F net. So 114 is going to be my F net. I'm looking for mass. What am I going to do with mass? Divide again, okay? So if I look at my triangle, I'm going to find that M equals F divided by A. So if I plug those numbers in, it's going to be 114 divided by 10.2. And we get 11.2. So my final answer in units is 11.2 kilograms because I was looking for mass. Alright, let's keep going. An object experiences 23.1 meters per second squared acceleration and has a mass of 152 kilograms. Find the force. Okay, so I have meters per second squared again. That's acceleration. So A equals 23.1. What variable goes with kilograms? F net or M? Mass. So mass is going to be 152. When you look for F, what do you do with your math? multiply, because F equals M times A. So we're going to do 152 times 23.1. And you get 3,511.2. Newtons will be your unit because you're looking for force. All right, how do we feel about force questions? Good? Okay? Like I said, it's going to be formatted the exact same way on your test tomorrow. Okay, the same table and everything. All right, Newton's third law. For every force, there is an equal and opposite. Yes. Okay, it will be an equal and opposite force. Being able to identify action-reaction pairs. So that's like, the action is you bouncing on a trampoline. The reaction is the trampoline pushing you up. Okay, action, reaction, stuff like that. Be able to determine which object experiences greater acceleration after a collision. We will talk about that down here. Remember, the smallest mass will have the greatest acceleration. Okay? So on number 1, remember smallest mass has greater acceleration. We want to decide which of these two objects has the greater acceleration. So a bicycle running into the side of the car. Will the bicycle or the car have greater acceleration? Bicycle, because it has smaller mass. Okay? A 7-kilogram bowling ball runs into a 3-kilogram pool ball. Which one has the greater acceleration? 3-kilogram pool ball, because it's smaller mass. A mouse runs into an elephant. Mouse, because it's smaller. Okay? Alright, last little section is momentum. All we're going to have on the test is PMV. We're not going to do the M1V1 stuff. Okay? So momentum, a measure of how hard it is to stop an object that is moving. Greater mass is greater momentum. Greater velocity is greater momentum. And then be able to solve momentum problems using the formula. So this is just like FMA, but now it's PMV. What does this P stand for?
No.
Momentum. Okay? The P is momentum. And remember, our momentum unit is kilograms times meters per second squared. Not squared, just meters per second. Take that away. M, of course, stands for mass. And we know that that is kilograms. And V is velocity. And that's meters per second. Now, let's go solve these problems. Alright, find the momentum of a zombie running at 3.4 meters per second and a mass of 82 kilograms. Where am I going to put 3.4? On velocity. Yep. You're good. Okay, because remember, meters per second goes with velocity. And what about 82 kilograms? Where does kilograms go? Mass. So that means I'm looking for P. I cover it up in my triangle. What do I do with M and V? Multiply, because they're beside each other. Okay? So P equals 82 times 3.4. mine known as P, so I'm going to use this unit up here, kilograms times meters per second. Any questions? Alright, I'm going to keep working then. What is the mass of a zombie that has a momentum of 850 kilograms times meters per second and a velocity of 9.8 meters per second? Where does this 850 go?
On momentum.
On P, yes, okay, because of this unit right here. That unit tells me that's P, so 850 goes with P. What about 9.8 meters per second?
Velocity.
That's velocity because of this unit here. What type of math do I do if I'm looking for M?
Dividing.
Divide. So M is going to end up equaling P divided by B. So 850 divided by 9.8. 86.7. And my unit is kilograms because I'm looking for mass. Alright, let's do one more, and then I'm going to talk about a few things, and then we are good for the day. Find the velocity of a 120 kilogram zombie. That's a momentum of 957 kilograms times meters per second. Where am I putting 120?
On mass.
Mass, because of kilograms. Where am I putting 957?
Momentum.
Momentum, which is the P, because it has that unit. V is going to be P divided by M. So 957 divided by 120. .9. And velocity is meters per second. Okay, there is one thing that is not on this test review that is on your test tomorrow, and that is vocabulary. Okay, so what I recommend doing, obviously keep track of your test review. I put it on yellow paper for a reason. Okay, you can use this on your test tomorrow. But I also want to show you how to get to your vocabulary to study tonight. Okay, you cannot use vocabulary on your test tomorrow. So on Canvas, the easiest way to get there, if you go to modules on the left, the Unit 8 vocabulary link is the first thing you should see. Okay? And then you have your vocabulary papers as well. Alright? So the only thing not on that test review is going to be vocabulary, but that's how you study it. I would go study those words the best that you can. Okay? Test is tomorrow, and then you'll find out what you made either tomorrow or Thursday, and we'll correct them on Friday if we need to. Sound good?